All right, Unit 11, Day 4, right? So now, still going to be graphing rational functions, but we're going to be adding in one more thing, right? I know one more thing here, but these rational functions can have something that's called a hole in the graph, okay? So a hole in the graph occurs when you can cancel out a common factor from the numerator and denominator, okay? So if you can cancel out something from the top and the bottom, then it has a hole in the graph, right? And a hole is a point. So big thing here, a hole is a point. So we need an X and a Y value. It's an undefined point on the graph, okay? So everything we've done so far is going to be the same. We're still going to find zeros, y-intercepts, vertical asymptotes, horizontal asymptotes, the same way, okay? The only new thing is if there's a hole, we need to find it, okay? So what we do is, if you look over here, this example of a graph here, right? We can see same horizontal asymptote, vertical asymptote still has two branches, y-intercept, x-intercept are 0, and then you've got a hole right here, right? And it's an open dot. That's showing as undefined. It's not actually part of the graph, right? So make sure when we put a hole on the graph, it is an open dot, okay? So, yeah, make sure hole is an open dot, all right? And then again, just so we can use the wave, right? If we need it, most of the time we won't need it, but sometimes we will, all right? So first examples here say determine if each rational function has a hole. If it does, find its coordinates. So if we look, number one's already factored for us. So if we look, there is a common factor here of x minus 1 that we can cancel out. So since we canceled it out, sorry, dog is hearing some stuff. So we cancel out x minus 1, so that means there's a hole in this graph. So the way we find that is we take x minus 1, whatever we canceled out, and we set it equal to 0. Okay? So we get add 1, and we get x equals 1. But remember, a hole, we need x and y. So we have an x. So what we do is we take whatever we have left here, get rid of that. So when we cancel out that x minus 1, we have x minus 2 over x left. So to find the y value, we plug in our x value. Right? Into what's left. So to find our y value, we're going to go y equals 1 minus 2 over 1 would be negative 1 over 1, which is negative 1. So the hole on this graph is going to be located at the point 1 comma negative 1 is where that hole is going to be, okay? That's the new addition to what we're finding, all right? Now, number 2, we got to factor a little bit, okay? So in the numerator, multiply to negative 2, add to 1 would be 2 and negative 1. So x minus 2, sorry, x plus 2, x minus 1 over in that denominator, multiply to 2, add to negative 3 would be negative 2 and negative 1. So x minus 2, x minus 1. Okay, and we look, x minus 1 we can cancel out. So what we have left would be x plus 2 over x minus 2. Okay, so again, to find the hole in the graph, we just go whatever we canceled out equals 0. So we get x equals 1, and then again, we got to find the y coordinate. So we got 1, so plug that in. 1 plus 2 over 1 minus 2 would be 3 over negative 1, which is negative 3. So the hole is going to be at 1 comma negative 3 for that function, okay? And then for this last one, again, if we look to factor, This time multiplies the 9, adds to -6, would be -3 and -3. And then on the bottom, there's two terms, so we can't use the big X. We look, there is a GCF, though, of X. So if we take that X out, we'd be left with X minus 2. Right? So if we look at this fraction, X minus 3 over X times X minus 2, there's nothing to cancel. So that means this thing, there is no hole in the graph. Okay, this one doesn't have one. So nothing to find there because there isn't one. All right, so we're taking that, adding it on to what we did before. All right, now for number 1 here, find all of this stuff, right? So this one's factored for us. So if we look, we can get rid of X minus 3, and we would be left with 1 over X, right? So since we canceled out X minus 3, that means there's a hole. So we set that equal to 0, and we get X equals 3. And then we plug that in to what we got left, right? So we go Y equals 1 over 3, right? So that means our hole is the point 3, 1/3. Okay? So that's what we're working with there. And then we find zeros. So remember, zeros come from the top, right? So the top equals 0. So we say 1 equals 0, which 1 does not equal 0. So that means this thing has no zeros, right? So we're not going to cross the x-axis. Vertical asymptotes come from the bottom. So x equals 0. Done. Easy. Horizontal asymptotes, we look at the degree. So you can look at what you got left or at the beginning, it doesn't really matter. So if we look at the top, the degree of the top, let me zoom in here a bit. So the degree of the top right? Degree of the top is just a 1. There's no x up there. So the degree of the top, since there is no x, is just 0. And then the degree of the bottom is x to the first. So top is smaller than the bottom. So when that happens, it's automatically at y equals 0. Okay? And then for our y-intercept, right, we plug in 0 for x. So if we go y equals 1 over 0, that is undefined, right? We can't have 0 on the bottom. So that means this thing has no y-intercept, right? And for the wave, we don't know if we need it yet. So let's put this stuff on here. So horizontal asymptote at 0, y equals 0. So horizontal asymptote. Vertical asymptote at x equals 0. Okay, no zeros to put on there, and then we've got a hole at 3, 1/3. So 3, and then up a third somewhere in there. Open dot, remember, because it's a hole. Okay, so now if we look, right, again, we've got a point, a hole up here in that quadrant. So there's going to be a branch in that quadrant, right? So if we go ahead and we put a branch that goes through that hole, right, we know that. And then in this case, there's no double roots. So that means our branches are diagonal. So our other one should be down here. Okay, and then that's what we got there. All right, so again, the new thing is finding the hole. Everything else, same. All right. Now for this guy, x minus 1, x plus 1 over x plus 2 squared. So remember, all that means is that there are two x plus 2's down here. Like that, all right? So if we look, nothing cancels here. So since nothing cancels, that means there is no hole in this graph, okay? Zeros, color did I use over here for zeros? Zeros, I used blue. So zeros, again, come from the top. So we've got x minus 1 equals 0, x plus 1 equals 0. So we got 1 and negative 1. Vertical asymptotes, I use green, I think. Vertical asymptotes come from the bottom. So x plus 2 equals 0. So we get negative 2. And again, there's two of those. So that means this thing is a double root. Since again, that means it's a double root, our branches aren't going to be diagonal anymore. So we might need the wave, okay? Horizontal asymptotes, check the degree. So if we look, right, this thing is factored for us already. So if we look at the x's, we've got 2 x's on the top. And then the bottom, again, factored, we got 1, 2. So top is equal to the bottom. So we divide the leading coefficient. So the numbers out front, we got a 1 and a 1. So y equals 1 is our horizontal asymptote, okay? Y-intercept, if we plug in 0 for x, so 0 minus 1, 0 plus 1 over 0 plus 2 squared, negative 1 times 1 over 2 squared. So that'd be negative 1 over 4. So 0 comma negative 1/4 for our y-intercept, okay? So let's put this all on the graph. So 0, negative 1/4. So somewhere in here, horizontal asymptote at y equals 1. So put that in there. Vertical asymptote at x equals negative 2. And then we've got zeros at 1 and negative 1. So we've got that. So now the issue is, right, we've got points down here. So we know a branch goes down here, but we don't know what in the world is going on there. And we don't know, we got a double root, so we don't know where the other one goes. So we're going to need the wave this time, unfortunately, okay? So remember, for the wave, we use critical points, right? Which again are zeros and your vertical asymptotes, okay? So for zeros, we got 1 and negative 1. Vertical asymptote, we've got negative 2. So smallest to biggest, we've got negative 2. There's our vertical asymptote. And then we've got negative 1 and 1, okay? So for our wave, leading coefficient is positive, right? Whole fraction up there is positive, so that means the right side is up. So we're up on the right. And then we have a double root at negative 2. So we're going to bounce at negative 2. So everywhere else we're going to cross. So we're going to cross at 1, cross at negative 1, and then we're going to bounce at 2. So we're going to see something like that. So again, if we break this up into sections, okay? So over here, whoops. There we go. Over here, when we're to the right of positive 1. So over in this area, we want to be positive, right? So we want to be above the x-axis. So we want to be up here, okay? And then when we're between 1 and negative 1, so in this area, right, between those two, we want to be negative. So we want to be down below the x-axis there, go through that y-intercept. And then when we're between negative 2 and negative 1, so in this little area, we want to be positive again. So we're going to go up this way. And we do actually cross through that y, or that horizontal asymptote this time. Kind of weird, right? And then as we go over here, when we're to the left of negative 2, so when we're over here to the left of negative 2, we want to be positive again. So the only way we're going to stay above that x-axis the whole time is if we're up here. Okay? Otherwise, we would cross that x-axis if we went below that horizontal asymptote. So that's what this graph looks like. This one's tough because you got to use the wave and all that stuff, but that's what we're working with, okay? Now, number 3, right? This one we can factor, okay? So in this case, we have in the top a difference of squares. So we could factor the top to be x plus 2, x minus 2. And then on the bottom, multiplies to negative 8 and adds to 2 would be 4 and negative 2. So x plus 4, x minus 2. Okay? And if we look, we can get rid of those x minus 2's. And what we're left with is x plus 2 over x plus 4. Okay, so we're going to work with that from now on. But since we canceled out x minus 2, that means there's a hole. So we set that equal to 0. All right, and then we plug that into what we have left. So we go 2 plus 2 over 2 plus 4 would be 4 over 6, which is 2/3. So our hole is at 2 comma 2/3. Okay, zeros come from the top. So at negative 2, vertical asymptotes come from the bottom. So x plus 4 equals 0. So x equals negative 4. Horizontal asymptotes, we look at the degree. So degree of the top is 1, degree of the bottom is 1. Or if you look at the original one, 2 and 2, they're equal, right? So top is equal to the bottom, so we take the leading coefficients. So we've got leading coefficients are 1 and 1, or again, 1 and 1. So y equals 1. And then our y-intercept, if we plug in what we've got here, again, you can plug it into the original or our simplified version over here. You get the same thing. Go 0 plus 2 over 0 plus 4 be 2 over 4, which is 1/2. So we've got 0 comma 1/2 for our y-intercept, right? So let's put it all on the graph. So y-intercept 0, 1/2, right there. Horizontal asymptote at y equals 1. Okay, vertical asymptote at y equals x equals negative 4. Zeros at x equals negative 2. And then there's a hole at 2 comma 2/3. So 2 at 2/3, somewhere up in there. Okay, now with this, right, we've got points down here. So there's going to be a branch down there, right? And then there's no double roots. So since there's no double roots, that means our branches will be diagonal. Okay, so that means our first branch, we said we got points down here. So it's going to come through that 0, through the y-intercept, through the hole, and go that way, and then diagonal up here, just like that. Okay, so that's what we got. And then this last one, again, got a little bit of factoring to do. So top multiplies to negative 20, adds to 1 would be 5 and negative 4. So x plus 5, x minus 4. And then in the bottom, multiplies to negative 12, adds to negative 1, negative 4, and positive 3. So x minus 4, x plus 3. And if we look, can get rid of those x minus 4s. So we're left with x plus 5 over x plus 3 to work with that, all right? So we do have a hole in the graph, right? Because we canceled out x minus 4. So we set that equal to 0. And then for the y coordinate of that, we plug it in. So that would be 9 over 7. So ugly number here. 4 comma 9 over 7 is where that hole is going to be. Zeros again from the top. So x equals negative 5 is a 0. Vertical asymptotes from the bottom. So x equals negative 3. Horizontal asymptotes, again, either your simplified version or the beginning one. Right? If you check the degree, they're both 2. So divide the leading coefficients. So 1 over 1 is 1. Okay? And then the y-intercept, plug in what you got. Again, from the original or the simplified, you'll get the same answer. Simplified's a little bit easier to work with. So 0 plus 5 over 0 plus 3 is 5 over 3. So 0 comma 5 over 3 is our y-intercept. So let's put it on the graph. So 0, 5 over 3. So that's 1 2/3. So somewhere in there. Horizontal asymptote at 1. Scoot over here. Vertical at negative 3. Okay. And then we have a 0 at negative 5. And then there's a hole at 4 comma 9 over 7. So 4, 9 over 7 is 1.2 something. So somewhere in there. Okay. So now if we look, we have points up here. And then we also have a point down here. So we don't need the wave, right? We know exactly where our 2 branches need to go. So if we put in our 2 branches, we got one that needs to come down through here. And then one that needs to come through here, right? So that's what we're working with, all right? So try out that homework again. May need to use the wave sometimes, may not. But find all that information, graph them. Let us know if you have any questions on that homework.